Welcome to today's class is Math with Joy. So today we're going to be looking at motion along an inclined plane. So whether you are a further math student, a physics student, please, this class is for you. I assure you that at the end of this video, anywhere you see question that has to do with motion along an inclined plane, you will jump at it and deal with it. So please do well to stay tuned to the end of this video. If you're yet to subscribe to our channel, do so. Like, share, comment, and also invite your friends. Okay, so now what is an inclined plane? So now for physics students, you know inclined plane to be a type of machine used to raise heavy loads, right? Now have you seen where drums of oil are being transported? Have you seen where drops of oil are being transported? You will see a big lorry waiting for the oil, and then you discover that this oil, individuals, human beings cannot lift them due to their weight. All right. Now, a plane, let's say a ladder, is placed on the lorry. All right. Now, that ladder is our plane, which forms an angle with the horizontal. The horizontal is the ground. All right. The ground is carrying both the lorry and the plane. Now, you see people trying to roll the oil up the ladder or the plane, whatever they place there, so as to make that oil to do what? To enter the truck. So that's a clear example, something you can easily picture, see in your mind. Another example, I don't know how many of you have been to the wharf where cars are being offloaded from containers. Now, how are those cars dropped down? You think they enter the container, start the car, and then the car drives itself down and then gets to the ground? No. So these are few examples of inclined plane. So now I want you to understand, I think I've explained what inclined plane is. So the next thing is, how do we resolve forces on the plane? So if you can resolve forces on the plane and solve WAEC standard question on this topic, I think you are good to go. All right. So now let's go. So now you have your inclined plane, which makes an angle of theta with the horizontal. Now your particle is on the plane. Let me extend this plane. So now this your particle has a mass of, we don't know until we get to start solving question. So this is a reaction. Remember that every particle weight acts towards downwards. So we have this to be our mg. All right. Now, this reaction is perpendicular to the plane. Did you see that? So we have an angle of what here? 90 degrees. Good. So now, this weight also forms an angle of 90 with the horizontal. Are you with me? Good. So now, how do I resolve this weight on both sides? Now, the force here, I have a force here, and then I also have a force here. So now this force is what we call the pull. That is what drags this particle upwards. And then this one here tries to do what? Drag it down. Now we also have the force of friction, which teams up with this force trying to drag the particle or the body down. All right. So now what is this and what is this? So you see that reaction makes an angle with what? With the weight, and that is our what? Focus. So let's call this beta. Now remember that the whole of this is 90 degrees. So if I've removed beta from 90, let's call the remaining angle alpha. All right, good. So that means alpha plus beta is equal to 90 degrees, reason complementary angles. I just shared angle 90 into 2, right? Good. Now, if you also look at this, you see you have a right angle triangle. This is 90. So theta plus alpha is also 90 degrees, right? Of course, sum of interior angles of a triangle is 180. So if this is 90, that means these two will sum up to give you the remaining 90. So the same reason, complementary angles, right? Good. So now if I make alpha, if I make beta a subject in the first one, I will have that beta is equal to 90 minus alpha. In the second equation, if I make theta subject, I will have theta to be equal to 90 minus alpha. So assuming alpha is 30, so you see that beta will be 60, theta will also be 60, right? So what does that tell you? That theta is equal to beta. Now, have you seen how or why these two angles are the same? So that is why in books you see theta here, you also see here to be theta. So that is the reason. Okay, now to resolve, I want to be seeing this diagram. So maybe I'll write on this side. I want to be looking at the diagram. Let's all be looking at this diagram. Now we've established that this is reaction. So how do we find this reaction? Now you will see that this reaction is perpendicular to the what? To the plane. While this other force is what? Parallel to the what? To the plane. Can you see it? They have two parallel lines, while this reaction is perpendicular. It cuts the plane at an angle of 90 degrees. Okay, so now let me pick out that triangle. So if you see me write theta, just know that it is the same thing as beta. We've established that. Okay, so I have the weight acting downwards to be mg, and then I'm looking for here. So let me call it reaction. All right, so you see that this reaction is adjacent to the angle of focus, so we'll be using cos. So cos theta is equal to reaction over weight. So since I'm looking for reaction, if I cross multiply, reaction becomes equal to mg cos theta. So have you seen where mg cos theta is coming from? Good. So the next thing is this weight or this force that is pulling this body down. How do I find it? Remember that this is also what? Parallel to the what? To the plane. So if by extension, if I extend this, you see that these two lines are what? Parallel to each other. And what do you know about this? They will be what? Equal, right? So I can use here. So if I use here this line that is parallel to this angle, that means the angle, it has no business with the angle. So that means it's opposite. All right, good. It is the one that is perpendicular that has something to do with the angle, which is why it is cosine. So now to give you a better view, look at this way. Let me fix it here. Now I have this, right? So let me call here x, let me call here y, and let me call here z. So transferring it here, I have x, I have y, I have z, right? And then I have the resultant of the forces or weights in between, right? Good. Now the angle of focus between the force or the weight, the angle of focus is between the force or the weight and the horizontal. Do you see it now? Good. So that means if I am to resolve here, it will be cosine, which was exactly what we did. So resolving here is the same thing as resolving here because it will be parallel and opposite, which is the same. So here will be what? This is opposite. So what will I have? I will have sine theta or beta. Remember I said the theta and beta are the same, to be equal to what? This is opposite. So let's call this a name. Let's say x. Okay, I think I've used x somewhere. Let me say k. Okay, so k over the hypotenuse, which is mg. So what is that k? It will be what? Mg sine theta. So have you seen the rationale behind the mg sine theta here? Is change in velocity acceleration will be 0. So whenever you see a question that has to do with constant speed, just know with that what acceleration is 0. All right. So what else have we established before solving the question? That smooth plane means there is no friction. Whenever you see a question and we are informed that the plane is very smooth, just know that there is no what? No friction. So we have no business with friction. All right. Good. So also know that after resolving weight on the parallel line on the lane parallel to the plane, we have mg sine theta, and the lane perpendicular to the plane, we have mg cos. We have 10g sine theta here. This is our reaction. And we are told that the force pulling this is what? Were we informed of anything? Let's just put our P here. Okay, so let's get back to the question. Okay, so the coefficient of friction is given. So we're just told that the force pulling it is P. All right. Okay, so we are to find that P. Beautiful. Now, how do we know that? Okay, we have two things. Seeking for the will give us the net force MA, right? Okay. So now, what is friction? Remember that the coefficient of friction mu is equal to friction over normal reaction. So this normal reaction is what? Is our mg cos theta. So that means if we cross multiply, friction becomes equal to what? Mu times mg cos theta. Is that clear? Good. So coming back to our equation here, we have P minus mu mg cos theta minus 10g cos theta. Remember that acceleration is 0. So 10 times 0 will give us 0. So we equate to 0. So substituting our values, P, I can actually take all these to the other side and then I'll add. So the coefficient of friction from the question is 0.3 times the mass, which is 10, times the force of gravity, which is also 10, times cos 40 plus, remember we took everything to the other side, 10 times 10 times cos, sorry, this should be sine, not cos. Okay, so now to find the component of the weight parallel to the plane is simply 8g sine theta. So that is 8 times our g is 9.8 times sine 40. So you can just put that straight into your calculator and that gives you 33.16 Newton. All right, good. So the next thing we are asked to find, the acceleration of the body. All right, okay. So we know that force is equal to ma. All right, good. So since we've gotten this force, you know that this is force, right? So we equate it to ma and then find our acceleration. So we have 33.16, which is equal to 8 times the acceleration. Dividing both sides by 8 to find our a, we have acceleration to be equal to 4.15 meter per second squared. As simple as ABC. So moving to the last but not the least question, the third question. Now we are told that a particle of mass 5 kg rests on a rough plane. So seeing that rough plane, that tells you that there is what? Friction. All right. Okay, so now the plane makes an angle of what? 30 degrees with the horizontal. And then this is where the particle is. What is the reaction? What is the weight? So the weight is 50 Newton, while the reaction is 50 cos 30. We have the mass to be 50 here. We have the weight acting down to what? To be 50 sine theta. Okay, now since we have the coefficient of friction, what does that tell us? It means that there is friction, but we don't know friction yet, so we put our FR. Okay, so this is our reaction. There is always a pull. If there is no pull, this weight will just follow the force dragging it down, right? Okay, so we are told that a particle is pulled up the plane. So the force pulling it up has been given to us as 60 Newton. So we are asked to find the normal reaction, and that normal reaction is equal to 50 cos theta. So what is cos 30? Cos 30 is 0.8660. So 50 times 0.8660 will give us what? 43.3 Newton. That is for the normal reaction. Then the next thing we are asked to find is the frictional force acting on the particle. So we don't know the frictional force, but we know the coefficient of friction. And we know that that coefficient of friction is equal to the force of friction over normal reaction. And what is normal reaction? Mg cos theta, right? Good. So to find friction, if you cross multiply, friction becomes equal to the coefficient of friction times normal reaction. So now all this information has been provided, so we're going to just substitute and find the friction. All right. So the force of friction is equal to, what's our coefficient of friction? We have it to be 0.2. We have the mass to be what? We'll have the mass to be 5 kg. In fact, mg is 50. Let's just move straight. And then cos theta, oh, we've gotten the normal reaction. Oh. So I think we don't need to do it all over again. We just carry the values and put the value and put there. So we have just 0.2 times 43.3. Okay, and what would that give us? So that will give us 8.66 as our friction. All right. So the last question on this, the last but not the least, is to find the acceleration of the particle, right? Okay. So now we'll look at the net force. I think from there we'll find our acceleration. So looking at the net force, we'll have the pull, which is heavier, minus the other forces contending for the particle, that is the force of friction, and the force dragging the weight down, which is what? mg sine theta, mg sine theta will give us ma. Good. So the pull has been provided in the question to be 60. We've gotten our force of friction to be 8.66. Okay, so the only thing we're here to get is our mg sine theta, but we know our mg to be 50 sine 30 is equal to 5a. Okay, so find sine 30 multiply it by 50, that will give us 25 because sine 30 is half, right? Okay, so if I add sine 30, if I add the 25 to 8.66, adding 25 to 8.66, we will have 33.66, and that is equal to 5a. Okay, so if I subtract 33.66 from 60, we'll have 26.34. So we have 26.34 to be equal to 5a. So since we are looking for acceleration, we divide both sides by 5. So what's our acceleration? Acceleration is 5.27 meter per second squared. Okay, so I believe that with these few points of mine,